Right, in my previous video I posted how we could implement these in assembly code, and in this video it looks simple but it's much more involved. Believe me, I'm going to try to explain how I can do this. Now my simulation is currently running, so let's just clear that for the moment, and let's just get rid of that. Okay, so I'm going to call test3 here. And this is my example. Now this example just relates to this, or as close as I can get to it. I'm going to load up some sample data, which just for the moment is all zeros, which isn't going to meet my condition because I want RB0, RB0 is that one, and then RB2 to actually be set. And this is the, these two lines are the most important part, or fairly critical to understand these. Anyway, everything is important, but this bit pattern defines which bits I need to look at on the input. Now, bits I'm not interested in testing, I set to ones. So I'm not interested in that. I'm not interested in these. Remember, I'm only interested in these two. Yeah, these two here, and then in this, for these bits, I then say what the value must be for the code to continue. So it must be that bit must be a 1 and that bit must be a 1. You don't have to use ones, but in this particular case I want those two bits to be a logic high. Now how I got there is going to probably confuse you, but let's have a go. So let's have a breakpoint there. Let's just run the code. Let's get these first couple of lines to run. Let's just loading up some test data. So you'll see that the working register now is 0. Port B is also 0, as we would expect. Now here, this line is actually just going to simulate getting the data from port B into the working register, but we already know what it is anyway. Let's just skip that line. So now in the working register I've got all zeros. Now if you think about, so this is an inclusive OR. Inclusive OR is just a logic OR. So like 0 or 0 is 0, 1 0 or 1 is 1, 1 or 0 is 1, output 1, and 1 or 1 is 1. So it's not an exclusive OR. That's an exclusive OR like that. So I'm going to inclusive OR those bits. So bitwise, taking this as an example, so 0 or 1 is going to be 1, so 0 or 1 is 1, etc. 0 or 0 is going to be 0, and 0 or 0 is going to be 0. Now inclusive OR, a literal value, and then save it back in the working register. So let's execute that line. So you see now we've got that in the working register. Now the next thing then is we're going to exclusive OR it with the bit pattern that we want. And because it's an exclusive OR, hopefully you can understand that 1 exclusive OR 1 is going to be 0. So all of these are going to be 0. This one, 0 exclusive OR 1, that's going to output a 1. 0 exclusive OR 1 is going to output a 1. So let's let that line of code run. So now you've got in the working register you've got 101. So 101 is not 0. It's not equal to 0. So the 0 bit, there's a status file and there's a Z bit. You'll see the Z bit is currently not set. It's clear. Hopefully you can see that. So with the Z bit being clear, not set, there's no match. Now, when we do have a match, we're going to skip the next line, but because we don't have a match, we're going to proceed to the next line and then go back through the loop again. So it will just then repeatedly go through the loop. Now, this time, let's modify the port B. So we give it the data which we're actually looking for, which the least significant bits are going to be 1, 0, 1. So that's a bit pattern that we're going to look for, because remember I said the zeros represent the bits which we're interested in, and then the ones represent the values that I'm actually after. So where are we? We're in that line at the moment, so let's just press F8. So we're going to move the file port B, so we're going to move port B, which is that. We're going to move that into the working register. So now we've got 101 in the working register, and then we're going to inclusive OR this literal value with that. Now hopefully you can see that if you inclusive OR that, so inclusive OR that with that, we're actually going to end up with all ones. Let's try it. Yeah, so we've got all ones now. Now if you exclusive OR all ones with all ones, you're actually going to output 0, because 1 exclusive OR 1 is 0, and that's can be replicated across all the bits. So now the working register is all zeros. Now because it's all zeros, the Z bit is now going to be set. So let's just have a look at that. So if you look in the status file, you'll see the Z bit is set. And because the Z bit is set, and we're looking to see the Z bit of the status register, bit test file, test the status file, and skip if the Z bit is set. So it's going to skip the next line, which it has done. So that is the way that I can test whether RB0 and RB2 are logic high. Now I know it's quite involved. It's worthwhile having a go with this yourselves, changing some bits around. You can do this test on whatever bit pattern you want. You don't have to be looking for logic high. You can also look for logic low as well. Good luck. Hopefully you'll figure it out.